I'll see if I can maybe field this, field the question a little bit about script lag. And, I won't, I'm not going to really say, well, that's a user issue, because it could be a lot of different things. But what I want to do is kind of talk about, like, how I understand the game engine to work and where script lag comes into play. Okay. So if I was to do this myself, a lot of times to help me understand something or to help me to get a grasp, or the term is like wrap your mind around it, of something, is I would ask myself, given the elements, giving the pieces of the puzzle, how would I put the puzzle together? How would I make it work? And that's true of almost anything. If it's something even industrial, what safety measures would a person use if you are in an industrial environment? Okay, so the way that I understand the system to work is you have a game engine, and this game engine it's made up of different components. So you have player input, whether it's keyboard, joystick, and you have a lot of things going on the screen. You've got objects being moved. You have objects, it would be like a mesh. You have objects being moved around on the screen, whether it's an NPC, or whether it's something that has physics, like a bottle gets knocked off the shelf, bullets. You have all these objects moving around in an XYZ, like a XYZ position. So you have all these things going on, and you want the game engine to be smooth. So what you want to do is you have to find a way to render a frame. It's a single snapshot of what you see. And if you flip through a bunch of these snapshots, what they call FPS, frames per second. So if you flip through a lot of frames per second, then what you get is the illusion of motion. Disney once called it the illusion of life. So it's the illusion of motion. Okay. So, all right. Now, the way I understand Bethesda kind of worked this whole system. So let's assuming that all game engines, like FPS and things like that, they all have the same components. You're going to have objects moving. You have to have time to update those objects, calculate collision, whether a bullet collides with a wall or collides with a person. You need to have those things. So let's assuming that's all the same. So what Bethesda did to extend the game, to extend it. So you have the core, and then to extend it, they created a scripting language that allows you to reference objects in the game and assign certain functions based off of events that the game engine generates. Like, for example, if you equip a piece of armor, the event might be called onEquip, but it needs a reference. So who is going to get that event? So if it's, let's say, you, the player, you would use the player reference. So player reference dot on equip, and then whatever the item, whatever. So when you equip it, I'm assuming it's either going to be based on an object. So an object can have an on equip event, and I believe it might be based on the object. Like I said, I'm not a scripter, but I believe it might be based on the object. So once an object is equipped, then you want to put that object on the player. Okay, so that's what the scripting engine does. It lets you do certain things. Now, Bethesda, from what I understand, they execute. So, like, you generate a frame that you see. It's a still image, and then in between the next still image that you generate, they allocate time to do something, like run a script. But the problem is, it doesn't just run one script. I believe it's priority. I don't think it's preemptive scripting. It might be. I've never heard it called that. Like, preemptive scripting is when you could be running something, but something says, I need to execute right now. It's not really based on priority, and or it could be based on priority, more than likely is, and it preempts. It immediately stops what's doing, and it preempts whatever currently is happening so it can run. They call that like preemptive scheduling, preemptive multitasking. So scripts are all running at the same time. So scripts, like, like scripts generally don't communicate with each other. They're all doing their own thing, and they can run. They can get events in any order, and there, you have to have a way to kind of mitigate the order in which things are done. But back to in between the frames. So a single frame is generated, and then they allocate a certain amount of time to generate the next frame. So they pause so many microseconds. Now, what happens is, so in this scripting system, let's say you got 20 scripts that need to run. So in the scripting system, let's say that you allocate, and this is a way overstatement because it's in the microseconds, but let's say you allocate like 1 second, and script number 1 doesn't get done because it's buzzing through a lot of code. It doesn't get done. So that 1 second is taken up. That means you have to wait for the next frame to do to try to finish up script 1. That's going to be a bad idea. So what they did, they tried to break it down in just little event blocks, and then they allocate so many microseconds per script. So if that script doesn't get done with its function, it'll be put on hold, and maybe I could be wrong, it might do the whole function, but I believe it gets put on hold, and then the next, because once that time allocated, it's an allotted time, I think they call it a tasklet, it's an allotted time, it will stop executing that script and execute the next chunk. So imagine you're piecemealing. You're grabbing a piece, from script 1 to script 10, piece, until each one is done. Now that can cause script lag because whatever needs to be done is not fully getting processed because its time is up. So now it needs to move on to the next script. Now what that does is that kind of, instead of like getting one thing done right off the bat, it gets everything done at the same time. So you have like tasklet time, but then you have the allotted time for all of the scripts to run. Even if they don't get that far, you only have so much time. So if you've got 30 scripts being run, and in the time allotted for all scripts, not the tasklet, but the little time between frames, the little still images that you're generating, if the current time exceeds that, it doesn't run the scripts. They're just stuck until they can get time. They can find a way to fit in that time, that tasklet total time space between frames to get executed. Now, normally, they execute pretty quick because they're compiled. It's not so much interpretive. It might be tokenized or bytecode, but it should run pretty quick. But the problem is that the scripts aren't always tight. So functions aren't always event-driven, and they're not really gated behind, let's say, a quest value, the current quest stage, or some other variable that can be used to gate certain features that says, okay, I can't do this until this value is set. And that's a lot of times what you see with quests where they break because there's no condition in there that takes account for whatever the current quest stage or stages are at. But back to the scripting. So things, from what I've heard, things like Sim Settlements 2, Pack Attack. I do know Pack Attack for 100% sure. I will get a completely flooded VM, and it doesn't happen all the time. It only happens when certain conditions exist, and I don't know what it is. It floods the VM with thousands of little script events will all hit, and it's the same NPC that somehow is getting caught recursively over and over and over again. Well, that floods the VM. So none of that is going to get done until it starts chunking away at it to free up some of the things so it can now move those back into the executable space. So that being said, there's a couple things you can do with scripts. So let's say you increase the tasklet time. If you increase the tasklet time, that's going to take away from other tasks in that between frame period. And that means that it's possible that some very complicated scripts are not going to get executed. You're going to see that as script lag. The next thing is, if you increase the time between the frames, then it means that their scripts now have a lot of time to run, but now you've got a bigger time period between the frames. So now your FPS starts to drop. So they decided that it's better for script lag to exist than for your frame rate to get killed. And I even have I see script lag from time to time, especially with Pack Attack. If there's a lot of enemies on the screen, there's a lot of stuff going on, and you will actually see, you're actually going to see script lag. And I'll notice that because I have, I think it's kill tips and sound effects by Tuin. So what'll happen is I'll shoot the thing and there'll be like a 1, 2, 3 second delay before I hear the sound, because that takes the script that long to actually fire off. It's script lag, especially if your VM gets overloaded. You don't know if you're, like, for example, let's say your VM gets overloaded. It'll actually do a dump. It'll dump something in your Papyrus that says, hey, there is too much there. I'm overloaded. I cannot even touch all of this stuff past a certain point until I clear some things out. So whatever is waiting is stuck. There's script lag. It's stuck until the VM can get to it. If you're on a console, you won't see that. If you're not running Papyrus and checking the Papyrus log, if you're not logging the Papyrus, you won't see that. So what I did is, in my application, I actually look at the Papyrus every time I save a game. So every single time that I go in to save a game, I will look at the Papyrus. And if I find a stack dump, I literally say, hey, there's a stack dump. So, and that's just an example of a symptom of script lag. Now, what you're seeing is things are getting stuck. So there's too many scripts being executed on the VM to get done in the time frame and the tasklet time. You got tasklet time and you got the time between frames, their FPS frames. So what can you do? Well, there's a couple things you can do. One of the things Bethesda did is they allocated a chunk of memory for the minimum stack frame memory-wise in bytes to allocate. You want to make that, you want to leave that one alone, because you have a minimum and a maximum. So if you set the minimum at too large of a value, then a lot of that memory is wasted. It's going to use more memory than what you need to use. So that's not a good thing. That's not a good thing. The second thing is, if you, let me see here, what was, okay, so also, if you increase the upper limit of the stack frame, then you might actually pick up some FPS simply because if the maximum, let's say, is 128 bytes or 128K, or let's say it's 128 bytes. If a stack frame needs more than 128, it will literally have to allocate more 128 blocks to get what it needs. So it's kind of like their memory management system. You give me a number and I'm going to make the best out of what you give me. I'm not going to tell you that you need to increase it. I'm not going to put a warning in the Papyrus that says, okay, I'm having to allocate multiple chunks of a stack frame because it's not big enough. So one of the things you can do is increase the maximum size. Baka has something that allows you to do that. That is one of the things Baka has. And I've noticed myself that if I use something like Baka, increase something, and there might be another one that does that. Buffout might do it as well, because I do know that they both try to manage memory outside of Bethesda's in-game memory management, which lets you allocate larger chunks of memory. I did notice an improvement in scripting. I did notice that. Things seem to run much smoother. I don't know if I have that now, but I did notice that when I used it. So you can do that. You can also, there's something Baka has that there's a limit to how many tasklets will run during that stack frame time, or during that frame time between frames, where all the tasklets, all the little tasklets get a certain amount of time. And then there's like I said, there's that time frame in between that. I think it's set at like 100 or 200 or something like that. You can increase that. I think I got mine increased to 400 or 500. So it doesn't mean it's going to do 400 or 500. It just means that if normally in the game, if you've got 300 little tasklets that's trying to run, and it gets to 100, and that's the limit. If it gets to 100 and there's more time, it ignores it. It just simply says, okay, time, the number that I wanted to do in this time is up. So if you have, and that would give you an increase in FPS. You'd see your FPS start to go up. It'd be tighter. So I've got mine like to 4 or 500. That will also affect FPS. Another thing that can affect script lag is your CPU. So, how is your CPU handling? Of course, there is balancing that exists with games so that certain CPUs or certain threads are assigned certain things. So, there's a balancing that way. But depending on what your CPU is, depending on how fast your CPU runs, how hot your CPU runs. If it's air cooled, it's going to thermal throttle. It's what they call thermal throttling. It's going to get too hot, so the CPU, to protect itself, is going to slow down. It's going to decrease its clock speed, because the more electricity you push through a wire, because wires are not 100% conductive, there's always a certain amount of resistance. Resistance equates to heat. So if you have something that has a little bit of resistance and you're pushing a little bit of electricity through it, it's going to get warm. But if you push a ton of a lot of voltage through those wires, and these wires are thinner than hairs, they're microscopic size. If you push it through that, it's going to get hot, really hot. So the CPU has little transistors that, when they get a certain temperature, they will. There are certain resistors. Transistors, which are sensitive to temperature, and you can put in so many volts on one end, and depending on the temperature of the transistor, you get a completely different voltage on the other end. And I don't know whether it's colder or hotter, if it goes up or down, but you can look at that variance and you can actually equate that to temperature. And that's kind of just a simple way they do it. So it'll thermal throttle. That can cause script lag. So that's another problem. If script lag can also be equated to loading things on and off a hard drive. 7,200 RPM are a little more expensive than 5,400 RPM standard hard drives, standard platter hard drives. An SSD is better because you're going to get better throughput because it's solid state. And it has a board on there that keeps track of the most commonly used files, and it kind of puts that in like a priority list. So if that SSD is strictly used for one game, then that game should be as fast as possible because that's the only game that's being used. So you got that as an issue. You've got graphics as an issue, because remember, frame rate and all that, the time a script executes is in between these frames being generated. So if you have a very, very high graphic load, so in other words, you're putting out really high textures and things that's causing your graphic card to really struggle, then as your FPS decreases because of GPU utilization or even the game's optimization, that is going to affect how often scripts are run. Those little tasks are actually executed because they are executed, if I understand it correctly, because they are executed in between those frames. So the less frames you have per second, the less those little things are getting executed. That's going to equate to script lag. So from a technical point of view, one of the things, like I said, you can do is you can leave your lower limit for your frame size. I think it's like 64 or 32 or something. I forget. You can leave it at like that. Your upper limit, you can increase that, but you don't want to make it so massive that it wastes a lot of memory, because remember, that's an upper limit. So if it goes over that limit, it's going to allocate another block of that same amount of memory. Like, let's say it allocates 256K and it only needs like 256,000 bytes when it only needs one single byte. So hopefully, I'm just kind of speculating here. So hopefully, when they go outside of Bethesda's way of allocating memory and they use system allocation routines, it'll allocate exactly what it needs. So it's a little more efficient because it gives the stack frame what it needs. You can, like I say, so you can try that, and then you might be able to try. Like I say, I don't know what your CPU is, your graphic card, all those things. Like I say, can affect the scripting, because scripting is run between frames. You've got so many microseconds allocated for each individual script that is executed between those frames. You can only execute so many scripts between those frames, and you only have so much time to execute all of the scripts it can between that frame. So you have those factors you have to kind of work with. So what I would do for me, if it was me, or like what I did here, is the first thing I did was I worked on the graphics. So I didn't really want to use Bethesda's high-res graphics. I went for more optimized graphics. So that gave me an immediate boost there. I use previs precombines. That gives me an FPS boost at that level. So at that point, that's if I leave the meshes the same. Oh, and I also now when I generated LOD, that increased the amount of data that has to be loaded, because now the LOD files are much bigger. There's more detail. They're bigger, and so not only are they bigger in a XY, a 2D space, but they have a lot more colors to it. So I'm assuming depth stays the same. So it's probably just the size of the file is bigger, not just the width and the height of the bitmap, but the actual size is bigger. You have that, so that would actually help. And other than that, you'd have to know, again, what your CPU is, what your clock rate is, your clock speed for your CPU, your memory speed, your motherboard throughput of data. All those things are going to play into that, because that affects your frame rate, which affects how much time a chunk of things can be allocated. Okay, so that being said, like I say, there's SS2, there's Pack Attack. I got thousands. I got 2,000 or 3,000 stack frames hit, and it completely fried my game save out. And it came from Pack Attack or Pace. I think it was Pack Attack, and it literally was the same call on the same MPC. It got stuck in a weird kind of a loop. So somehow the events hit at such a time that they just started recursively calling each other, and that is going to be massive script lag. Script lag can be caused by other things. I don't want this video to go on too long, but it can be caused by other things where you have, let me check the time here, where you have programmer error, or I don't want to say improperly designed scripts or code that's written, but things that are not accounted for can cause a problem. It can be a lot of different things. So anyways, I hope that helps. I don't know how well I did to field the question, but that's kind of like script lag and how it works, because a lot of the game is scripts. It's basically scripts. That's what handles most of the game that you play. So anytime you have script lag, that's going to affect certain things. Now, outside of script lag, you might have like collision detection, let's say being able to loot inventory. There are certain things that have priority. It'll take priority to give the illusion that the FPS is there, even though the things running in the background trying to process stuff is taking too long before you hear like a gunshot hit something or before something reacts. That's script lag. All right, so I hope that helps, and feel free to throw anything up you want, or if you got any more questions, just holler out.